again from the question number 7 from the GATE 2021 Mechanical Engineering Set 1, which is from the machining operation or the machining design, you can say, subject. So, in which they are asking if a cutting tool traces a workpiece such that the directrix is perpendicular to the plane of the generatrix as shown in the figure, the surface generated is right. So before again like we did in the previous question, before going to the solution, we just have a quick rewind of the concepts behind it. So I'll start with the feed motion and the cutting motion. Let us suppose we have a workpiece here and we have a tool here, right? Now this tool can reciprocate. In order to cut this part of the workpiece, this tool can reciprocate here, right? So after a successive iteration of this is cutting motion, this tool will eventually be able to cut this part of the workpiece, right? So but once this work part will be cut, so this motion is called as the cutting motion, right? Cutting motion of the tool. Now once this part will be cut, would this workpiece so if this tool work again on this part, would this able to cut the workpiece in the next section? So it won't, right? Because our workpiece is because our workpiece can be sliding but our tool is stationary. So what we have to do is we have to slide our workpiece to the tool so that our workpiece if we want to cut this region, if we want to cut this region, we have to slide our workpiece, right? So we after cutting this portion, we have to slide our workpiece to this part so that our tool can also cut this portion, and similarly consecutive events will happen. So this type of the motion in which we are feeding our workpiece to the tool so that it can be efficiently cut, so that motion is called as the feeding motion, right? So in more technical terms, the line generated along the cutting motion is called as the generatrix, while the line generated along the feed motion is called as the directrix. So let us suppose we want to plot it in the 2D scale, like in the cutting motion is here and the feed motion is here, right? So the lines which are generated along the cutting motion, like the cutting motion would be here. So these are the horizontal, sorry, vertical lines, right? So and the cutting motion would be sorry, the feed motion would be the horizontal flat lines, right? So the resulting surface it will generate out of it would be, as you can see, would be a flat surface, right? Similarly, in case of the this workpiece which is in a rotating form, right? So in that case, our workpiece is stationary, and our tool will act as a feed. Our tool will act as a feeder, right? So our workpiece will keep on rotating at its normal, at its single axis, right? It will keep on rotating along its axis, right? So what happens, our tool will keep on feeding to the forward so that the necessary portions, whatever the required in case of the machining operation or the lathe turning operation it is, so it can be cut. So while cutting, so while analyzing the feed motion and the cutting motion of this also, so we just assume like it would happen, it would create the scenarios like this, right? Like this, like this, like this, like this, like this, like this, right? So here we have this region. So as you can now clearly see, the resulting portion which it will come out of it would be a cylindrical portion, would be a cylindrical portion, right? So again, it's committed to memory. Thing is like when the directrix is linear and the generatrix also linear, so the resulting surface would be plane surface, like it is happening in this case. Our directrix was also linear, like here this was cutting motion, and our feed motion was also linear. So in that case, the resulting surface that would be generating would be a flat surface, right? But in this case, but in other case, when the directrix is linear and the generatrix is circular, the resulting surface would be cylindrical surface. And either is the case when the circular directrix is circular and the generatrix is linear, the resulting surface would be cylindrical surface, right? So here is the case. In this case, the directrix is linear, and the directrix, by directrix I mean to say is the by directrix I mean to say it is the line which is happening along the feed motion, like this thing. And our generatrix is the our generatrix is circular, like so the right. So the resulting surface would be the cylindrical surface. Now let us go back to our question. So he's asking, when the directrix is perpendicular to the plane of the generatrix, so which case it is the second case, like our directrix is linear and generatrix is circular, so the resulting surface it would generate is the cylindrical surface. And in order to guess it more fast, you just have to see if if a directrix is circular, or the cutting tool is circular, or sorry, the feed motion is circular, and the generatrix is the, I mean, this horizontal. So the resulting surface it would generate would be a cylindrical surface. So in this case, the option B is the correct answer, right?